For our project, we decided to focus on freefall acceleration and terminal velocity. We wanted to see how terminal velocity changes with different masses. Freefall acceleration is when an object moves under the influence of gravity only and no other forces. It is always directed vertically downward with a magnitude of 9.8 meters per second squared. Terminal velocity is the constant speed that a freely falling object eventually reaches when the resistance of the medium through which it is falling prevents further acceleration. Drag is the sum of all the aerodynamic forces in the direction of the external fluid flow. It acts to oppose the motion of the object. For our experiment, we use a tape measure, painter's tape, a food scale, a ruler, and 5 cupcake liners. The ruler was used to find the diameter of the cupcake liners. The food scale was used to find the mass of 1, 3, and 5 cupcake liners. We then used the tape and tape measurer to mark 1 meter off the ground, that way each drop was from the same height. In this part of the experiment, we videotaped dropping 1 cupcake liner from 1 meter and then ran it through the video analysis app. That gave us a time versus velocity graph that showed the experimental velocity to be negative 2.3536 meters per second. This time around, we recorded dropping 3 cupcake liners and put it through the video analysis app. Then it gave us a graph for the time versus velocity that showed our experimental velocity to be negative 5.4898 meters per second. All the same steps were repeated, this time with 5 cupcake liners. In the end, the graph showed an experimental velocity value of negative 4.6952 meters per second. For each of the trials, we calculated the predicted terminal velocity values for the cupcake liners. We used the equation at the top left and filled in numerically with the data we had to obtain the 3 predicted values. At this step, we had to pay close attention to the units as everything had to be the same in order to cancel out at the end to get meters per second. Once the trials were finished, we obtained our experimental values for the terminal velocity and compared it to our predicted values. Now that we have obtained both our theoretical and experimental values, we use the percent error equation shown to see how close we were to the actual terminal velocity values. Once calculated, our lowest percent error was for trial 2. A source of error that could have occurred in trial 1 or 2 could have been from the initial calculations of terminal velocity. Another source of error could have been from when the experiment took place, causing the experimental terminal velocity number to be larger than expected. Overall, we are satisfied with our percent errors as they are towards the lower side.